Do you know? There are three styles of data integration. Hi, I'm Bindu Kumar, and in this video, I'm going to show you the three styles of data integration along with examples for each style. We will then compare these three different styles across various characteristics. At the end of this video, we will discuss why it is so important to be aware of these differences. Hi everyone. So in this session, we are going to talk about data integration, right? So data integration is a term that you often hear across the data industry, right? So what exactly is data integration? What are the three styles of data integration, right? So in this session, we are going to talk about the three different styles of data integration and why it's so important, right? Now, before we do that, let's quickly look at a quick definition of data integration. So if you look in the Wikipedia, data integration is defined as combining data residing in different sources and providing users with a unified view of them. If I were to elaborate it a little bit, it's about collecting data from various different systems, storing it in a centralized location like a centralized database, and then sharing that data with other users, right? So this is the textbook definition of data integration. But what has happened over time is data integration as a term is used anywhere where there is data exchange. So if one application is sharing data with another application, it's also considered as data integration, right? So this is what we have to be aware of. Now, if you look at the second bullet point, there is something called as electronic data interchange, or EDI. So this was a term that was coined several years ago when companies started sharing data between them through various interfaces, and this came to be known as electronic data interchange. But sometimes this abbreviation is corrupted. It is also called as or referred to as electronic data integration, right? So now in the industry, the data integration means different things to different organizations. Sometimes it's the textbook example or the textbook definition, which is combining data from different systems. And in some cases, it involves exchanging information between different organizations. So this is an overall description of what data integration is about. Now let's look at the different styles of data integration. So we are looking at style 1, which is B2B or app-to-app data integration. Here B2B stands for business to business. Now look at the picture here. Here we have a person who has a card, maybe a debit card or a credit card. So he uses it in an ATM that belongs to Bank of America. Now let us assume that this card that he's using actually is a card issued by Citibank, right? So as you know, Bank of America and Citibank are two popular banks in US. So when this person uses a Citibank card in the Bank of America ATM, the cash is still dispersed, right? Assume that it's a withdrawal that is happening, right? So the cash is still withdrawn by the person. So how does this work, right? So here is where you have to bring in the concept of data integration between the two different banks. So it works something like this. When the person swipes the card or inserts the card into the ATM, the Bank of America ATM sends some amount of information to the centralized Bank of America server, right? And the data might look something like this, right? So you have the customer ID, date, time, the card bank, right? The bank to which the card belongs, or the bank that has issued the card type, the transaction type, and few other details. Now, once the server receives this information, it realizes that the issuing bank is a different bank. It's not Bank of America. So the same information is transferred to the Citibank for validation. It's a way of saying that, okay, hey, look, there is a person that's using my ATM, but the card belongs to you. So is this a valid transaction, right? And then Citibank, the server in the Citibank would respond to this message, which looks something like this, saying, okay, it's verified, it's a verified person. And then the message is first received by the Bank of America servers, which is then transferred to the Bank of America ATM, and finally the cash is dispersed, right? So there is a lot of message or information that is exchanged between these different servers, right? Now here if you see, there is information exchange between two different businesses. In this case, it is Bank of America and Citibank, right? So this is also referred to as business to business data integration, or it is also referred as electronic data interchange, okay, between two or more businesses. Sometimes it is also referred as app to app data integration. Now let's look at one more example. So all of you must have visited one of these websites like Trivago that aggregates hotel information or flight information from many different websites, right? So here is an example where this person is trying to book a hotel through the Trivago website, but Trivago it itself does not own any hotels, right? So what they do is they aggregate information from many different chain of hotels like Marriott, Aloft, Oyo, and so on. So when you visit this website, and let's say you input a particular date and then you give a particular location and you're trying to book a hotel, Trivago on that instant should communicate with all these different providers to get the information, right? So this is very similar to the previous example where there is data interchange between these different businesses. So here Trivago being one of the business and Marriott, Aloft, Oyo being the other businesses. So there is data interchange between the different businesses. So let's say finally you like a particular hotel and a fare, and you block it or you reserve it. Once that is done, again the information goes from the person to Trivago, from the Trivago to Marriott, and let's say Marriott responds with a confirmation saying that yes, this particular room is available on so and so date and this is the fare, and now it is blocked or reserved for a particular person, right? And that information is sent back to Trivago, and Trivago then sends it back to the customer in various formats. It may be through a browser, it may be through an email confirmation, or maybe even through a mobile message, or all of these combined together, right? So this is also an example of B2B data integration. Now let's understand the characteristics of such data integration. This is very important, right? As an example, I think it's very easy for all of you to understand, but it's very important to understand the characteristics. So the first characteristics, the size of data exchange or the volume of data that is shared between these different businesses at every transaction, right? So the volume of data exchange is quite minimal, right? So they always want to keep it minimal because you don't want to share high amount of information or high volume of information because it slows down the entire process. So the focus here is on exchanging the minimal amount of information. Second characteristic, frequency of data exchange. So what triggers the data exchange in the first place? The data exchange happens only when there is a transaction, right? When there is a transaction. So unless you visit Trivago and look for a hotel and book it, there is no data transfer between Trivago and the, let's say, Marriott, right? So the frequency of data exchange is purely based on the transactions that happen. The next characteristics is direction of travel. right? So in what direction does the data travel? Is it unidirectional or bidirectional? So in this style 1 of B2B data integration, it's clearly bidirectional data transfer, right? So Trivago is sending some data to Marriott, and Marriott is then sending back some data to Trivago. So the data is traveling in both ways, hence bidirectional. The fourth characteristic is extent of transformations. Now, what do I mean by transformations? Transformations refer to the process by which data which is received is modified in some form or the other. In case of a B2B data integration, the data undergoes no transformations or minimal transformations at best, because you have to look at the the speed at which these transactions have to occur, right? Which is sort of explained in point number 5. Right, the transactions have to happen immediately. I mean, take the example of the ATM transaction, right? In an ATM transaction, once you punch in your details and you are looking forward to withdraw some cash, you don't want to wait for minutes together. The transaction has to happen immediately, right? Which means the entire process has to be fast, and you have to do everything that you can to make it fast. So one of the thing is you reduce the volume of data being sent, right? Second, you avoid doing any unnecessary transformations to the data, because every transformation will incur some kind of a cost. Now that was point number 4. The point number 5, the timeliness of transactions, right? So what is the timeliness? Meaning, how quickly is this transaction completed? So in a B2B kind of a data integration, the expectation is these transactions complete in real time or in synchronous, right? So what is synchronous? Synchronous means the transaction has to be confirmed by all the parties. Okay, so let me explain it with this example. Now, if this person is punching in all the details in the ATM, right, the transaction is now sort of confirmed by the person, but it has to be verified by the Bank of America as well as the Citibank as soon as possible. Only then will the cash be dispersed to the customer, right? So here, unless all the parties agree to the transaction is not committed, right? So which means it is synchronous. Until all the parties agree to the transaction is never considered to be done, right? So this is called a synchronous transaction, right? So in this B2B kind of data integration, it is you will see that the transactions have to be either real time or synchronous. So there are some applications that have been traditionally supporting these kind of data integration. So one of the the ones that came out earlier was the Microsoft BizTalk. So BizTalk stands for business talk. So business to business talk. So here you would have two, let's say, Microsoft BizTalk servers. For example, Bank of America would have one server and Citibank would have one server, and they would talk to each other by sharing XML files, because XML was the standard before JSON, right? So Bank of America would send something to the Citibank would receive it, do some rules, run some rules to it, handle it, and then send a file back to Bank of America BizTalk server. Then you also had IBM App Connect, which was another server that was similar to this. Now over time, these technologies have been replaced with REST APIs or GraphQL APIs. These APIs bring in a lot more flexibility, lot more compatibility. They are more open to be used by many other organizations. Now, so let me take a pause here. Any questions on the style 1 of data integration? Okay, so I take the silence as no questions. Let's move on to the style 2. So what is style 2 of data integration? It is called as data replication. Data replication is also a process where data is exchanged, but it's for different reasons. So in this slide, you can see that there is a primary database which often has to share the data with other databases. So what do I mean by share the data? So you have a primary database, and let's say this database is very critical and you want to set up, you want to have some kind of a backup or a standby database. So in the event that the primary database goes down, or there is some kind of a software or a hardware failure, your application should not be impacted, right? So in which case you set up one or more standby databases. So what you're seeing on the slide right now is one such illustration where a primary database has 2 standby servers, probably distributed over different geographical location. So every time changes are made to the primary database, these changes are applied to the standby databases as well, right? And you see a blue line. This blue line represents the changes that are being transferred across the database, right? So in this example, all the changes are being applied on the primary database, and these changes are then mirrored or replicated to the different standby databases. Okay, but here also, if you see, there is data that is being interchanged between different systems. These may not represent businesses, but these are different systems. So here is another example. This is to be specific, it's about PostgreSQL. So PostgreSQL has the concept of a streaming replication, meaning any changes that are happening to the primary database are eventually applied to the standby database. Now I used a word called eventually applying, right? So what does that mean? Eventually applying means it is not a synchronous transaction. So anytime a change is made to the primary database, it may be committed to the standby database within few seconds. So there may be a lag of few seconds, or maybe in some cases few minutes as well. But does the data replication always happen within the same kind of databases? So for example, here we have the primary database is also Postgres and the standby database is also Postgres. Is this the rule? No, it's not, right? You can have data replication happen between different kind of databases as well. So in this slide, you'll see we have SQL Server on the left side. Consider this as the primary database, and we have a Hadoop database on the extreme right side. Maybe for archival reasons, every data that is created or that is modified here in SQL Server, we want to push those changes or replicate those changes into Hadoop. There are several mechanisms of doing it, but maybe one of the method that we have chosen is through Apache Kafka streams. In this case, this is also considered as data replication, right? So the data is moving from a database of one type to a database of another type through some kind of a Kafka streams, or it could be other methods as well. So all these different examples are examples of data replication. So the data replication is also sometimes referred as data mirroring. Now let's look at the characteristics of it. First, the size of data exchange. So for every transaction that happens, or for every message that is transferred between the primary database and the secondary database, it's often minimal data, right? Or it represents the data that is actually changed. So for example, if you inserted 10 records into the primary database, that same 10 records are going to be transferred to the secondary database as well, right? So it's purely based on the transactions that occur on the primary database. Second is the frequency of data exchange. So at what frequency does this exchange happens? This again depends on the transactions that happen on the primary database. Then the direction of travel. So the direction of travel here is unidirectional, right? So this is different from the previous style where the data exchange was often bidirectional, but here it is unidirectional because the data is always transferred from the primary database to the secondary database, but never in the reverse order. Then the extent of transformations. Extent of transformation is none or minimal. So if I were to look at this particular example, which involves Postgres, it is no transformations. Data that is inserted in the primary database, those exact same transactions are applied as is on the standby database. But if you look at this example, there is a small possibility that data is being transformed as it moves from SQL Server to Hadoop. Why? Because Hadoop may have different data types or different format in which the data is stored, which means the data has to be transformed before it can be stored. Then the last characteristic, which is the timeliness of transactions. So here it's not real time or synchronous, it is near real time or asynchronous. So suppose I insert 1000 records into the SQL Server database. There is no need for all those 1000 records to be immediately available in Hadoop, right? So we can insert the 10,000 records and we can consider the transaction to be committed, and maybe within few seconds, few minutes, or maybe even few hours, the data appears in the Hadoop database. So that is called asynchronous data integration. So here are some examples of tools that help you do it. You have Attunity, you have Debezium, Kafka, and of course the inbuilt database replication that comes with every database. Any questions on this topic?
Just one question.
So if
what's the time between if you're using a Kafka, what is the downtime? Like if it is the replication happens within seconds, minutes, like how efficient is Kafka?
It all depends on how often you need the data, right? So let's say you are okay to have data that is 1 day old, which means you can run your Kafka consumers, the Kafka consumer program maybe once a day, right, overnight, so that you get all the data from Kafka and put it into your Hadoop database, right? Or if your need is more frequent, maybe you need data every 1 hour, in which case you can run the consumer every 1 hour. So it purely depends on the need of the on the requirement, basically, right? Do you need real-time data, or are you okay with data that is 1 day old as well? Did I answer your question?
Yeah, thank you.
Any more questions?
Yeah, I have one question. So you were telling that data will be automatically replicated for Postgres, right? So do we have to create one secondary database, or is it automatically taken care, the replication?
So when talking specifically about Postgres, in Postgres there is a feature called replication. So what you'll have to do is you'll have to set up 2 different servers, right? So this is your database in the primary server, and this is another identical database in another server. Once it's done, you will have to set up the configuration of the primary database to say that this is your master database, and on the second database you have to configure it to say that this is the standby database, and you have to set up the replication. And here you also have to provide the address of the primary database. So you have to say that, okay, you are now a standby database and you have to consume the data from the primary database, for which this is the host name, this is the port, and this is these are the other details like login information and so on. So once the connection information is provided to the standby database, it automatically starts receiving the transactions as they occur in the primary database. Did I answer your question?
Yeah, got it.
Any real-time examples that we can have, like where we apply this kind of replication?
So one example could be in systems that are business critical. For example, banking systems, right? So all the banking applications have some kind of a database, and there is always a risk of either a software crash or a hardware crash or a hardware failure. So when that happens, you don't want your application to be impacted, right? Because you're supporting millions of customers. So what you do is, you have a primary database. You also set up multiple secondary databases. One example could be, let's say your operations are running in Bangalore, and in Bangalore, due to heavy rain, there is an outage of electricity and so on. So what do? Your data centers might run on backup power for only so much time. So what you can do is, you can set up your primary database in Bangalore and your standby database in, let's say, Hyderabad, right? And every time there are changes that are happening to the database in Bangalore, the transactions are being slowly applied to the secondary database in Hyderabad. And in case when there is an outage and the Bangalore server is no longer operational, you can immediately promote the server in Hyderabad to be the primary database. Right. So this is one real-time example where it is used in mission critical applications. Did I answer your question?
Yes, thank you.
Now let's move on to the last style of data integration, which is ETL, or extract, transform and load. So this is the kind of data integration that we are mostly involved with, right? So what is this third style of data integration? The third style of data integration is exactly what we heard about, what is mentioned in Wikipedia. It's about collecting data from various systems, storing it in a central location, and sharing that data as a unified view. So in this slide, you can see on the left side, there's something called as a data source layer. Now this layer represents all the different data sources from where we will receive the data. Then there is something called as ETL. So ETL is the data pipeline. ETL is a process, ETL is a technology that lets you collect data from these various systems and then store it in a central location. That central location is represented by this big box here in the middle, right? So here you'll see there are various levels: bronze, silver, and gold level, and so on. But we will discuss these details in a different session. I will have a separate session where we will do a deep dive into the architecture, where I'll give a breakdown of each of these different components, right? But for now, let's look at this central block as one centralized place where all the data that is being collected is being stored. Now, once the data is stored, there are many things that happen to the data. We clean the data, we integrate the data, we standardize the data based on various rules, and so on. So there are many transformations that are applied to the data, and then finally this data is then shared with the users through various interfaces. So in this diagram, you can see I have mentioned 3 of the popular interfaces. You have an SQL interface, you have an API interface, and then you have some kind of a dashboarding tool like Tableau, Power BI, and so on. So what is the benefit here? The benefit here is, if this kind of a data integration does not exist, the user will often have to connect to 20 or 30 different systems to fetch the data that they need. But with a data integration of the ETL kind, you're fetching the data from all the different systems, storing it in one central location, which enables hundreds or maybe even thousands of users to connect to one source of truth to get the data that they need, right? So we are solving a very big problem for them, which would have taken them, ages together to get all the data. So we are solving it once, and then that data is being shared with hundreds or maybe even thousands of users. So this is the third style of data integration. Now let's look at the characteristics of it. The first thing that will get your attention is the volume of data exchange. So unlike style 1 and style 2, where the data interchange was minimal, here it is bulk of data, right? Why? Because we are connecting to many different systems and we are sourcing all the data that is there, right? So typically you will see that the volume of data that is being received or ingested is in bulk. It is not in single transactions. The second characteristic is frequency of data exchange. So if you recall, in style 1 and 2, the frequency was purely based on the transaction that used to happen. So when a person goes to an ATM, then there is a data exchange. Or when you visit a travel website and when you look for a particular hotel, then there is a information exchange. But here, the frequency of data exchange purely depends on intervals. As a question came up before, right? How often do we fetch the data? Like, is it every minute? Is it every hour? Or is it once a day? So totally dependent on the time interval that is fixed. So typically in data integration projects, it's once a day, right? So you have jobs that run overnight, which fetch all the data from these backend systems, right? So the frequency of data exchange is not transactional. It's purely based on fixed time intervals. The next characteristic is direction of travel. Here again, it's unidirectional. So the data starts its journey from the data source layer. It is often pulled by the ETL process and pushed into the centralized data store or data warehouse, and then the data is again consumed by these different interfaces. So if you see, the data starts its journey from the left and move towards the right, and it often stays in this direction, right? Only in exceptional cases does the data travel back from, let's say, from any of these interfaces back to the source system as a feedback loop. But otherwise, it's often unidirectional in travel. Then, extent of transformations. So as I already mentioned a minute ago, you apply many different kind of transformations as the data moves through. So, for example, standardizing a name or changing a data format, removing a time component, or maybe fixing some data quality issues. For example, New York may be stored as New York or NY, right? So for the sake of consistency, you will update NY to, you'll expand it to the full term, which is New York, right? That's just one of the example of how you enrich the data. So likewise, there are many transformations that are applied to the data. Finally, the timeliness of transactions. So here again is usually a batch job or asynchronous job, meaning there is no need of data being available in the SQL layer as soon as it changes in the data source layer, right? So as I said, the data is often copied once a day, mostly off hours. So you connect once to the source system and you fetch all the data, and then you push it to the centralized data warehouse, right? So the timeliness of transaction is usually batch job and asynchronous. So here are some examples. You have Talent, you have Informatica, SSIS, Ab Initio. There are many more ETL tools that are in the market, but these are some of the popular ones. So any questions on style 3? If there are no questions, let's quickly compare all the three different styles together. So characteristic, size of data exchange or the volume of data exchange. In style 1, which is B2B, it is minimal, and so it is in the DB replication as well. In ETL, it is usually bulk of data that is exchanged. Data transformation, none or minimal in style 1 and 2. In ETL, there is usually many transformations that are applied to the data. The direction of data exchange is bidirectional in B2B, and in DB replication and ETL, it is usually unidirectional. But there is an exception. In distributed databases, it is common to see bidirectional exchange of information. But that's an advanced topic. It's a discussion for another day. Consistency of transactions. So when do you consider the transaction to be complete, right? So in a B2B, it is synchronous, meaning all the sending, the parties on either side of the transaction, they have to confirm that the transaction is committed. So that is why it is usually synchronous in the style 1. In style 2 and style 3, it is usually asynchronous, meaning as long as the transaction is committed by the first party or the primary machine or the primary database, it is considered to be completed. So the data is eventually replicated or transferred to the other systems. And then the last characteristics, the frequency of exchange. Now this is very important, right? So in B2B, it is transactions. So it's purely based on the transactions that occur. In the database replication side also, it's the same. It's the transaction that happen on the database. But when it comes to ETL, it is usually a fixed interval, fixed time interval. So it's every hour, once a day, every 6 hours, and so on. Now, these were the comparisons. Now, why is this important, right? Why is this distinction so important? So here are the 4 reasons. First is skilling, right? Now, let's say you are putting up a team, or you yourself want to work on one of these 3 different styles of integration. You need to know what is the kind of technology that you need to pick. So if it's style 1, which is business to business data integration, in today's day and age, API rules it, right? So you have REST APIs that are the standard for data interchange between different applications. So then you know that REST APIs is what you need to pick as a skill. But if the kind of data integration is towards ETL, where you're fetching bulk information, then API is not a good fit. You have ETL tools, you have JDBC drivers through which you can collect data. They are much more better at doing bulk transformations. So skilling is the first point. Second is the job description. Now, many times when people create job descriptions, they use these term data integration as a blanket term, right? They just say we are looking for a data integration developer. And I have had scenarios where some of my friends, they thought it was an ETL requirement, but once they joined, they realized it was more of an API requirement, right? So it's very important that you look at the job description, you ask questions, you try to understand what is the style of data integration it is. Third, challenges and principles. You see, the kind of challenges that you face in an API are very different from the challenges that you find, let's say, when you're dealing with ETL, right? They are completely different dynamics. They are completely different ways to solve the problems. So you can't expect someone who has worked, who is an expert in ETL, to solve the problems that happen on the API side. And the other way around as well. Somebody who's very good in an API, API kind of data integration, there is no guarantee that that person will be good in the ETL side of things. In fact, many of the ways or the techniques you use itself are different between all these 3 different styles. So the challenges of principles themselves are different, which is why you need to know what is the kind of data integration you are dealing with. Finally, the technology, right? So assuming you are responsible for setting up a data integration project, and you are responsible for identifying the technology as well, right? The entire technology stack. So it definitely helps if you already know the kind of data integration that you're trying to do. Now, I've had scenarios where people used ETL tools to set up business to business data integration, and they failed spectacularly, right? So, which is why you need to know what is the kind of data integration you're getting into, so that you can choose the right tool for the job. Okay. So with this, we come to the end of the session. Hi. I hope you found this video useful. If you did, please do hit the like button. It often takes hours to prepare and edit a video like this. You can support me by subscribing to my channel. It may be just one click for you, but it means a lot to me. Thank you and see you in the next video.